Are you struggling to understand AI? Do you want to understand AI from basics? Let's deep dive into AI world. We are going to explore the major technologies that make artificial intelligence possible. When people hear the term AI, they often think about ChatGPT, self-driving cars, or robots. But behind these applications are several important AI technologies working together. We will cover machine learning, deep learning, natural language processing, computer vision, robotics, and expert systems. By the end of this video, you will understand what each technology does and where it's used in the real world. Okay, let's start with machine learning, often called ML. Machine learning is a branch of AI that allows computers to learn from data instead of being explicitly programmed for every situation. The system analyzes data, finds patterns, and improves its performance over time. Think about how humans learn. We learn by observing examples and experiences. Machine learning works in a similar way. The more quality data it receives, the better it becomes at making predictions and decisions. Okay, let's discuss types of machine learning. The first type is supervised learning. In this approach, the AI learns from labeled data. This means the training data already contains the correct answers. For example, if we want to train an AI to identify spam emails, we provide emails labeled as spam and not spam. The model learns from these examples and can then classify new emails correctly. Okay. Common applications include spam detection, house price prediction, and disease diagnosis. Okay. The second type is unsupervised learning. Here the data does not contain correct answers or labels. The AI tries to find hidden patterns and relationships on its own. For example, an online shopping company. Okay. So a company may use unsupervised learning to group customers with similar purchasing behavior. Okay. The customers which are having similar behavior have one group. The another customers having other kind of behavior have the another group. Like that. AI finds the patterns and then build the relationship on its own. Okay. This is commonly used for customer segmentation, pattern discovery, and recommendation systems. The third type is reinforcement learning. In this approach, the AI learns through trial and error. The system performs actions and receives rewards for good decisions and penalties for bad decisions. Okay. So it is like similar way if you teach any child, if he does the right action, you give some reward as a like give 2 chocolates. But in case he does something wrong, then you take back 1 chocolate out of those 2 as a penalty. Similar way, here we are going to train AI, where if AI is taking the good decisions, then we will give the reward, and if bad decisions, then penalty. Okay. So over time, it learns the best strategy to achieve its goal. Example include self-driving car, robotics, and AI systems that play games like chess and Go. Okay. So these 3 main approaches, one goal, making machines smart. Now let's understand how machine learning actually works. Machine learning follows a step-by-step process to learn from data and make intelligent decisions. The first step is collecting data from various sources. This data could be customer information, emails, images, videos, sensor readings, website activity, or even social media posts. The quality and the quantity of data are extremely important because better data usually leads to better results. Once the data is collected, it is cleaned and prepared. This means removing errors, duplicates, or incomplete information so the model can learn effectively. Okay. So next we train a machine. Okay. So we train a machine learning model using this prepared data. During training, the model analyzes thousands or even millions of examples to understand relationships and patterns hidden within the data. For example, if we train a model to identify spam emails, it studies characteristics such as suspicious words, unusual links, and sender information. As the model processes more examples, it becomes better at recognizing these patterns. After training is complete, the model can be tested using new data it has never seen before. This helps us measure how accurately it has learned. Okay. Once the model performs well, it can be deployed to make predictions or decisions. Okay. So now we can test it to make predictions or decisions in real world situations. For example, it can classify emails as spam, recommend movies, predict sales, or detect fraud. As new data becomes available over time, the model can be retrained and improved, allowing it to become more accurate and effective. Okay. So the ability to learn from data, improve with experience, and make predictions is what makes machine learning so powerful. So to make this process easier to understand, let's look at a real world example of machine learning that most of us use every day. That is email spam filtering. Let's look at one of the most common examples of machine learning that we use every day, email spam detection. Every day, email providers receive millions of emails. Some are legitimate messages from friends, colleagues, or businesses, while others are spam emails containing advertisements, scams, or phishing attempts. To solve this problem, a machine learning model is trained using thousands or even millions of emails that have already been labeled as spam or not spam. During training, the model analyzes these emails and learns common patterns. For example, spam emails may contain suspicious links, excessive promotional words, unusual sender addresses, or certain phrases that frequently appear in unwanted messages. The model doesn't memorize individual emails. Instead, it learns the patterns that distinguish spam from legitimate messages. Now, when a new email arrives in your inbox, the trained model quickly analyzes it and compares it with the patterns it has learned. Okay. Based on this analysis, it predicts whether the email is likely to be spam or not. Okay. If the email appears suspicious, it is automatically moved to the spam folder. Okay. Otherwise, it is delivered to your inbox. As users continue marking emails as spam or not spam manually also, the system receives more data and can be retrained to become even more accurate over time. This is a great example of how machine learning learns from past data and uses that knowledge to make intelligent decisions automatically. Spam detection is just one example. In reality, machine learning is being used in many industries and applications. Let's explore some real-world use cases next. Machine learning is everywhere around us. Netflix and YouTube use it to recommend content. Okay. Online shopping websites use it to suggest products. Bank use it to detect fraud. Healthcare system uses it to predict disease. And spam filter uses to predict the email is spam or not spam. Whenever you see a system making predictions based on past data, machine learning is usually involved. Okay, let's summarize machine learning. Machine learning helps computers learn from data and experience. Instead of relying only on predefined rules, it discovers patterns automatically. It continuously improves as more data becomes available. This technology forms the foundation for many advanced AI applications we use today. Okay, now let's move on to deep learning. Deep learning is a specialized and more advanced form of machine learning. As the amount of data in the world started growing rapidly, traditional machine learning techniques began facing challenges when dealing with very complex tasks such as image recognition, speech understanding, language translation, and self-driving cars. To solve these challenges, researchers developed deep learning. Deep learning can automatically learn complex features and patterns from large amounts of data without requiring humans to manually define many rules or characteristics. Okay, it uses structures called neural networks, which are inspired by the way neurons in the human brain communicate with each other. Okay, these neural networks contain multiple layers. which is why the term deep learning is used. Each layer processes information and passes its results to the next layer. As the data moves through these layers, the network gradually learns more detailed and complex patterns. For example, when identifying a cat in an image, the first layer may detect edges. The next layer may identify shapes such as ears and eyes, and deeper layers may recognize the complete cat. Deep learning is particularly useful when working with huge amounts of data such as images, videos, audio recordings, and text documents. Many of today's most advanced AI applications, including ChatGPT, voice assistants, facial recognition systems, and self-driving cars, are powered by deep learning. Now that we understand what deep learning is, let's see how these neural networks actually process information and learn from data. Okay, let's understand how deep learning actually works. Deep learning works using layers of artificial neurons that are organized into a neural network. You can think of these layers as a team working together to solve a problem. Each layer performs a small part of the task and passes its results to the next layer. The process begins with the input layer, which receives raw data. This data could be an image, a piece of text, an audio recording, or even a video. Next, the data moves through the one or more hidden layers. This is where most of the learning happens. Okay. Each hidden layer analyzes the information and extracts useful features. The first hidden layers usually learn simple patterns, while deep layers learn more complex patterns. For example, if the input is a photo of a dog, the first hidden layer might detect edges and lines. The next layer may identify shapes such as ears, eyes, and a nose. Deeper layers combine these features and recognize that the object in the image is actually a dog. This step-by-step learning process allows deep learning models to understand very complex information automatically. Finally, the processed information reaches the output layer, okay, which produces the final result or prediction. For example, it may identify whether an image contains a cat or a dog, recognize a spoken word, translate a sentence, or predict the next word in a conversation. The more training data the network sees, the better it becomes at recognizing patterns and making accurate predictions. This ability to learn multiple levels of features automatically is what makes deep learning so powerful. Because deep learning can learn these complex patterns automatically, it performs exceptionally well when working with very large amounts of data. Okay? One of the biggest strengths of deep learning is its ability to process massive amounts of data. It can analyze images, speech, videos, and text with remarkable accuracy. Because it learns highly complex patterns, it often performs better than traditional machine learning in tasks involving unstructured data. This is why deep learning powers many modern AI breakthroughs. Okay? Deep learning is behind many technologies we use daily. Self-driving cars use it to understand road and traffic. Voice assistants use it to understand speech. ChatGPT uses deep learning to generate human-like responses. AI image generators use deep learning to create realistic images from text prompts. These systems become possible because deep learning can process large amounts of information. Okay. To summarize, deep learning is an advanced form of machine learning. It uses neural networks inspired by the human brain. It learns complex patterns automatically and performs extremely well on large datasets. Many of today's most impressive AI applications are powered by deep learning. Okay. Next, let's explore NLP, which stands for Natural Language Processing. NLP is the technology that helps computers understand, interpret, and generate human language. As humans, we communicate naturally using words, sentences, speech, and different languages. However, computers do not naturally understand language the way humans do. They only understand data and instructions. Without NLP, computers would struggle to understand what we write or say. For example, if you asked a computer a question in plain English, it would not know the meaning of the words, the intent behind the question, or how to respond appropriately. NLP bridges this gap by helping computers understand the structure and the meaning of language. It allows AI systems to recognize words, understand context, identify intentions, and generate meaningful responses. This is the technology that enables AI to read text, understand speech, translate languages, answer questions, and even hold conversations with humans. For example, when you ask ChatGPT a question, speak to Siri or Alexa, or use Google Translate, NLP is working behind the scenes to understand your request and provide useful response. In simple terms, NLP enables communication between humans and AI systems, making interactions feel more natural and intuitive. Now that we know what NLP is, let's look at the different components and capabilities that help computers understand human language. Okay? Now let's look at some of the key components of natural language processing or NLP. NLP deals with both written and spoken language, allowing computers to understand and communicate with humans more naturally. One important component is language understanding. This helps AI understand the meaning, context, and intent behind words and sentences. For example, when you ask ChatGPT a question, it first tries to understand what you are actually asking. Another component is speech recognition. This converts spoken words into text. Voice assistants like Siri, Alexa, and Google Assistant use speech recognition to understand voice commands. NLP also includes language translation, which allows AI systems to convert text from one language to another. Services like Google Translate use this capability. Another powerful component is text generation. Okay. This enables AI to create human-like text, such as answering questions, writing emails, generating articles, or having conversations. NLP can also perform sentiment analysis, which determines whether a piece of text expresses a positive, negative, or neutral opinion. Companies often use this to analyze customer reviews and social media comments. When you ask a question to an AI chatbot, several NLP components work together. First, the system understands your words and intent, then it processes the information and generates a meaningful response in natural language. This combination of understanding and generation is what makes modern AI assistants feel intelligent and conversational. Okay, so now we understand how NLP works. NLP deals with both written and spoken language. It includes tasks such as language understanding, speech recognition, translation, text generation, and sentiment analysis. When you ask a question to an AI chatbot, NLP helps the system understand your intent and generate an appropriate response. Okay, now that we understand the main components of NLP and we know how NLP works, let's see some of the amazing things NLP powered systems can do in real world applications. NLP is used every day in many applications. Google Translate translates languages. Voice assistants like Siri and Alexa understand spoken commands. Chatbots answer customer questions. Email systems suggest replies and detect spam. Whenever AI interacts through language, NLP is working behind the scenes. Okay, let's summarize. NLP serves as the bridge between humans and AI. It enables machines to understand and generate language. Without NLP, communicating with AI would be much more difficult. This technology makes AI systems more natural, accessible, and useful. Okay, now let's discuss computer vision. Computer vision is a branch of artificial intelligence that enables computers and machines to see, analyze, and understand visual information from the world around them. Okay, just as humans use their eyes and brain to observe and interpret what they see, AI systems use cameras to capture images or videos and algorithms to understand them. For humans, recognizing a face, reading a signboard, or identifying a car happens almost instantly. However, computers do not naturally understand visual information. To a computer, an image is simply a collection of pixels and numbers. Computer vision helps AI convert those pixels into meaningful information. It teaches machines to recognize objects, people, text, colors, shapes, and even activities occurring in a video. For example, when you unlock your smartphone using facial recognition, the system uses computer vision to detect and verify your face. Similarly, self driving cars use computer vision to identify roads, traffic signs, pedestrians, and other vehicles. In simple terms, computer vision gives AI the ability to understand and interpret images and videos, allowing machines to make intelligent decisions based on what they see. Okay. Now that we know what computer vision is, let's look at how AI actually processes images and videos to understand the visual world. Now let's understand how computer vision works. The process begins by capturing images or videos using cameras, smartphones, drones, CCTV systems, or other devices. Okay. Once the image or video is captured, the AI processes the visual data. Remember, a computer doesn't see an image the way humans do. It sees the image as millions of tiny pixels, where each pixel contains information about color and brightness. Computer vision algorithms analyze these pixels and look for patterns within the image. They identify features such as edges, shapes, textures, colors, and movements. As the AI processes more information, it starts recognizing objects and understanding what is present in the image. For example, it can distinguish between a person, a car, a traffic sign, or an animal. In videos, computer vision can also track movement and understand how objects change positions over time. Based on this analysis, the system can recognize and understand what it sees and then make intelligent decisions or provide useful information. For example, a self-driving car can detect pedestrians and traffic signals, while a facial recognition system can identify a person from a photograph. This ability to convert visual data into meaningful information is what makes computer vision such a powerful AI technology. Now that we understand how computer vision processes images and videos, let's look at some of the tasks it can perform in real world applications. Okay. Computer vision is widely used today, like face unlock on smartphones, medical image analysis, security surveillance systems, traffic monitoring and self-driving vehicles, smart shopping, etc. Okay. So these applications use computer vision to interpret visual information and make smart decisions. Now we know what computer vision can do. So it can detect faces, it can recognize objects, it can read text from images, it can identify defects in products, it can track movements in video, identify traffic signs, and can do medical scan analysis. So all of these are the capabilities of computer vision. These capabilities allow machines to understand visual information similarly to humans. Okay, let's summarize. Computer vision allows AI to understand the visual world. It transforms images and videos into meaningful information. This technology is essential for many modern intelligent systems. Okay, now let's move on to robotics. Robotics is a field of technology that focuses on designing, building, and operating robots that can perform tasks automatically or with minimal human intervention. Okay, robotics combines artificial intelligence with physical machines. While AI provides the intelligence and decision making capabilities, the robot provides the physical body that can interact with the real world. Think of AI as the brain and robot as the body. Okay. Together they enable machines to perform useful tasks in real world environments. Robots can move and sense their surroundings using sensors, cameras, microphones, and other devices. They then process this information and make decisions. and perform actions based on what they observe. For example, a warehouse robot can detect packages, determine the best path to reach them, and move them to the correct location. Similarly, a robotic vacuum cleaner can navigate around furniture while cleaning your home. AI helps robots become smarter and more adaptable. Instead of simply following fixed instructions, AI powered robots can learn from experience, adjust to changing environments, recognize objects, and make better decisions over time. This combination of intelligence and physical action is what makes robotics such an exciting and rapidly growing field. This combination of intelligence and physical action is what makes robotics such an exciting and rapidly growing field. Now that we understand what robotics is, let's see how robots actually sense, think, and act to perform tasks in the real world. Okay, now let's understand how robotics works. Most robots follow a continuous cycle of sensing, thinking, deciding, and acting. The first step is sensing the environment. Robots use sensors, cameras, microphones, GPS devices, and other technologies to gather information about their surroundings. For example, a self-driving car uses cameras to detect traffic signs, sensors to measure distance from nearby vehicles, and GPS to determine its location. Similarly, a robotic vacuum cleaner uses sensors to detect walls, furniture, and obstacles. Once the robot collects this information, it moves to the next step, which is analyzing the data. The robot's software or AI system processes the information and tries to understand what is happening around it. Next comes decision making. Based on the analysis, the robot decides what action it should take. For example, a self-driving car detects a red traffic light. It decides to stop. If a warehouse robot detects an obstacle in its path, it decides to move around it. After making a decision, the robot performs an action. This could involve moving, picking up an object, turning, speaking, or carrying out another task. Finally, the robot receives feedback from its sensors about the results of its action. This feedback helps it determine whether the action was successful and what it should do next. This cycle of sensing, analyzing, deciding, acting, and learning from feedback repeats continuously, allowing robots to operate effectively in dynamic environments. This is how modern robots can perform tasks intelligently and adapt to changing situations. Now that we understand how robots work, let's look at some real-world examples where robotics is transforming industries and everyday life. Examples of robotics include industrial robots in factories, delivery robots, medical robots, home cleaning robots, and autonomous vehicles. Okay, these machines help automate tasks that may be repetitive, dangerous, or require high precision. Okay, AI makes robots smarter. AI enhances robotic capabilities. It helps robots understand surroundings, make decisions, learn from experience, and work automatically and also adapt to changing conditions. Without AI, robots would simply follow fixed instructions. Okay, so this is how AI makes robot smarter. Let's summarize. Robotics combines hardware, sensors, software, and AI. Together, these technologies allow robots to perform useful tasks and solve real-world problems. Okay, let's explore expert systems. Expert systems are one of the earliest forms of artificial intelligence. They are AI programs designed to mimic the decision-making abilities of human experts in a specific domain. The main goal of an expert system is to solve problems and provide recommendations in the same way a knowledgeable professional would. Okay. For example, imagine visiting a doctor. Okay. The doctor asks questions, analyzes your symptoms, applies medical knowledge, and then suggests a diagnosis. An expert system works in a similar way. Instead of learning from large amounts of data like machine learning systems, expert systems rely on stored knowledge and predefined logic rules, which are created by human experts. When a user provides information, the system compares it against its knowledge base and applies logical reasoning to reach a conclusion or recommendations. Okay. For example, an expert system in healthcare may ask about symptoms and then suggest possible medical conditions. Similarly, a technical support expert system can help diagnose computer or network issues based on the information provided by the user. Because they use expert knowledge and logical rules, expert systems can provide consistent decisions and recommendations for specific types of problems. In simple terms, an expert system acts like a digital expert that helps users make informed decisions based on stored knowledge and reasoning. Okay, now that we understand what an expert system is, let's look at its key components and see how it actually makes decisions. Okay, now let's understand how an expert system works. An expert system mainly consists of two important components: the knowledge base, okay, and the inference engine. The first component is the knowledge base. Think of the knowledge base as a digital library that stores expert knowledge about a specific domain. It contains facts, rules, procedures, and information collected from experienced professionals. For example, in a medical expert system, the knowledge base may contain information about disease, symptoms, treatments, and diagnostic rules provided by doctors. In a technical support system, it may contain troubleshooting steps and solutions for common problems. The quality of an expert system largely depends on the quality and accuracy of its knowledge base. Okay, so knowledge base is very important here, okay, in the expert system. If the stored knowledge base is incomplete or incorrect, the recommendations may also be inaccurate. Okay, the second component is inference engine. Okay, the inference engine acts like the brain of the system. It takes the information provided by the user, then it evaluates different possibilities and determines the most appropriate recommendations or solution. For example, if a user reports symptoms such as fever, cough, and fatigue, the inference engine checks these symptoms against the medical rules stored in the knowledge base, okay, and suggests possible diagnosis. The overall process is quite simple. First, the user provides information or answer questions. Okay. Next, the inference engine analyzes that information using the knowledge base. Finally, the system produces recommendations, solutions, or decisions based on its reasoning. In simple terms, the knowledge base provides expertise while the inference engine uses that expertise to solve problems and assist users in making decisions and providing solutions. Okay, now that we understand how expert systems work internally, let's look at some real world examples where they are used to provide expert level recommendations and support. Expert systems are used in medical diagnosis, banking systems, customer support, troubleshooting systems, loan approvals, okay, financial planning, legal support systems, and also customer services. They help users make decisions based on expert knowledge. Okay. In expert system, knowledge base is very important. So let's see again. The knowledge base acts like a digital library of expertise. Okay. It contains facts, rules, and expert knowledge collected from specialists. The quality of the expert system depends heavily on the quality of its knowledge base. Okay. On basis of that only, AI is going to make any decisions and solutions. So the inference engine is also depends on knowledge base to make decisions and provide solutions. Okay. To summarize, expert systems use stored knowledge and logical rules to solve problems. They are designed to provide expert level recommendations and support decision making. Okay. Let's conclude by reviewing all the technologies which we have learned Machine learning enables computers to learn from data and improve with experience. The more quality data it receives, the smarter and more accurate it becomes. Okay. Deep learning takes machine learning a step further by learning complex patterns automatically. It's the technology behind many of the today's most advanced AI breakthroughs, including ChatGPT and self-driving cars. Okay. NLP bridges the communication gap between humans and machines. It allows AI to understand, interpret, and generate human language naturally. Okay. Computer vision gives AI the power to understand the visual world. It transforms images and videos into meaningful information that machines can act upon. Okay. Robotics brings AI into physical world by combining intelligence with machines. Robots can perform tasks, adapt to environments, and assist humans in the countless ways. Okay. Expert systems capture human expertise and use logical reasoning to solve problems. They act like digital experts, helping users make informed decisions. Okay. AI is not a single technology. It's a collection of powerful technologies working together to make machines smarter. While these technologies have different purposes, they often work together to create the intelligent systems we use every day. From ChatGPT and voice assistants to self-driving cars and smart robots, modern AI is built on these powerful technologies. Understanding these foundations is the first step toward understanding artificial intelligence itself. Thank you for watching. If you found this video helpful, please like, share, and subscribe to TECVKY for more AI and technology tutorials. See you in the next video.